Hey guys. Oh. Start over there. This was your homework question, so start here. And we'll do that so you can watch it right away. Okay. Yeah, just for fun, put your name if you're here in the comments. Just say, hi, Mr. Botsy, so-and-so. So this is your homework question. What is the mass of a ball of iron 2 meters in diameter, given that iron has a density of 7.85 grams per centimeter cubed? And give your answer in tons. So I've solved the problem and I've broken it down into all the discrete steps that you have to go through to think your way through it. First of all, you need this formula. The volume of a sphere is 4 over 3 pi r cubed. You need the density formula. Density equals mass over volume. And you need those three conversion factors. You need to know that 1 kilogram equals 1,000 grams, that 1 ton equals 1,000 kilograms, and that 1 meter equals 100 centimeters. If you know those three conversion factors, you can answer the question the way I posed it. So the very first part of this problem solving approach is to find the diameter of a ball in centimeters. Why would I do that? Because the density is usually expressed in units of grams per centimeter cubed. So you got to align all the units so that the numbers make sense. I see one person online. Oh, well. Okay, so we start off with 2 meters. There's 100 centimeters per meter, so that allows me to cancel meters. 2 times 100 gives you 200 centimeters, so this ball of iron is 200 centimeters in height. Half the diameter is going to give you the radius, so you take in your number one supporter, like what? Yeah, Mark Matty. Yeah, you're not even in the class. So radius is 100 centimeters, and then finding diameter in centimeters. So you've got 100 centimeters of radius. Then you plug it into the sphere's volume. To find the volume of the sphere, you plug it in the formula: 4 over 3 pi times the radius, in this case 100 centimeters, raise it to the power of 3. This is the answer you get: 4,188,790 centimeters cubed. So you found the volume of the iron ball. Now you're going to take the density formula, density equals mass over volume, and you multiply both sides by volume, and that allows you to cancel volume on the right, and you get volume times density gives you the mass. So you've isolated the variable, and you get the mass, which is what you're really looking for, all by itself, and then these two quantities you're going to know. This one you were given in the question, this you just figured out over here. So now all you have to do is plug in the two numbers, the volume of the thing and its density. The centimeters cubed cancel, and you're left with an answer in grams. That is the mass of the steel, of the iron ball, in grams. And we convert it to tons by first converting to kilograms. 1,000 is 1,000 grams per kilogram. Grams will cancel. And then there's 1 ton per 1,000 kilograms. And kilograms will cancel, which I forgot to cross out. Not a big deal, though. And the result is that the iron ball, 2 meters in height, weighs 32.9 tons. Now, if you were to do the same calculation, except now the ball is 3 meters in height and it's made of aluminum. Aluminum has a density of 2.71 grams per centimeter cubed, which of the two is heavier? That's the challenge question. You notice that This question puts together pretty much everything you've learned so far, not too much on the scientific notation, but it does have all the conversion factors and using of a formula and working with isolating the variable. So let's erase to make room for our new calculation. Better still, we'll do it, no, I'll leave it there so you can read the question. So the first thing we're gonna do is find the diameter of the aluminum ball. Let's just write the mass of the iron ball. So, iron ball weighs 32.9 tons. Now let's erase the answer, and let me take you through it a second time, but with the aluminum ball. And we'll find out which one is heavier. So we're told the ball is now 3 meters across. So we're going to convert to centimeters. There's 100 centimeters per 1 meter. Meters cancel, so you get a 300 centimeter ball. But it's made of aluminum. Half of the diameter is what we call the radius. So in this case, the radius is equal to 150 centimeters. Now we can plug that into the volume formula. So the volume of a sphere is given by 4/3 pi r cubed. Plug in the numbers then, 4 pi times 150 centimeters all cubed. You can use your calculator to solve that. I can't do that in my head. I doubt you can either. 150 y to the x to the power of 3, that's what you get there. Multiply that by pi, if I can find it, there it is, times 4 divided 3, and here we go. The answer you get is 14,137,166.9 centimeters cubed. That is the volume of the sphere made of aluminum. Now we're going to find its mass. Since density equals mass over volume, multiply both sides by V. The V's cancel on this side, and you've isolated the mass. So mass is equal to density times volume, but in this case, the density of aluminum is 2.71 grams per centimeter cubed, and the volume is this number, 14,137,166.9 centimeters cubed. Centimeters cubed is going to cancel, so your answer is going to be in grams. So multiply the number that is still in my calculator by 2.71, and it gives me the weight of the ball, the aluminum ball, 3 meters in height, 38,311,722.4 grams. Let's convert that to kilograms by saying 1 kilogram for every 1,000 grams, and convert that to tons by saying 1,000 kilograms for every ton. So basically, we're dividing this number by 1,000,000. So that's going to move the decimal place over by 6. So the answer you get is, after sig figs, 38.3 tons. So the aluminum ball, 3 meters in height, would weigh 38.3 tons, and the iron ball would weigh 32.9. So this is 3 meters, this is 2 meters, and that's 38.3 tons. So even though it's made of a metal that's less dense, the fact that you make it a 3 meter diameter more than makes up for it, and as it turns out, the aluminum ball weighs more than the iron ball, although the iron ball is definitely denser. So I'm going to cut it short there because these uploads take forever to go. They take 1 or 2 days, so you're not going to be able to watch it if you weren't here, and there's only 2 people here, so this technique isn't going to work very well. I'm going to start recording the class, which will be uploaded in an hour for using the other format. So I'll stop it now.